What is a salt? Salt comes from its own acids. Part 4. A salt is an ionic compound formed when the hydrogen of an acid is completely or partially replaced by a metal ion or ammonium ion. Salts are neutral. These are acids losing proton, creating salt ion. The salt ion are called conjugate base because they have lost the H+. The hydrochloric acid losing H+ to form chloride minus, so that is a conjugate base, and salt ion has one H, it's losing one H+, hence 1 minus, 1 H, 1 minus. All these acids are losing 1 H plus, and therefore they have minus as a negative charge, 1 minus. This is nitrate from nitric acid. This is iodide from hydroiodic acid. Oxalic acid has 2 H's, so it's lost those 2 H's, and you have 2 minus because it's lost 2 plus. Carbonic acid has 2 H, therefore the carbonate is 2 minus. Sulfuric acid has 2 H, therefore the sulfate is 2 minus. Phosphoric acid has 3H, therefore the phosphate is 3 minus. Because they are from their acids, they are salt ions. It is the salt ion that joins with a metal to form a neutral salt. Let's form a salt from sulfuric acid. Sulfuric acid will dissociate to form 2H plus SO4 2 minus. This is the sulfate ion coming from sulfuric acid. The sulfate ion is now going to combine with some of these metal ion and ammonium ion. The sulfate is going to combine with aluminum 3 plus. The sulfate is 2 minus. So now we're going to swap the superscript value with the subscript value for the opposite compound. The aluminum, the 3 in aluminum, we go to the subscript of sulfate, and the 2, we go to the subscript of aluminum. That's why you got 2 aluminum coming from there and 3 sulfate coming from there. That's how you form the salt compound. Now the calcium 2 plus and sulfate 2 minus, because they're the same number, we just write calcium sulfate. Because the superscript number is 2 here and this one is 2 here and they're the same, we just write calcium sulfate. There's no difference to the ratio, is 1 to 1. For ammonium ion, the ammonium ion is +1, so this is 1, and we give that 1 to sulfate, and there's a 1 here, and sulfate has 2, we give that 2 to ammonium, that's where you got the 2 there. So we're swapping the subscript charge for the opposite one. So now we got ammonium 2 sulfate. For sodium ion, which is +1, sodium is in group 1, calcium is in group 2, aluminum is in group 3. That's why you have those charges there. These are the oxidation number. So for sodium, the oxidation number is +1. The sulfate is 2 minus. So we take the 2 from sulfate here, we give it to the subscript of sodium, so that goes there, and we take 1 and give it to the subscript of sulfate, so we have 1 sulfate, sodium 2 sulfate. So now you can see the formation of salt, the salt itself, then mixing with metal ion or ammonium ion, which is what we said here, to then form the salt. And the salt are neutral, they have no charges. Let's try phosphoric acid. Phosphoric acid has 3 hydrogens, and it is losing the 3 hydrogen to form 3H plus phosphate. Because we have 3 here, we have to have 3 minus here because it has lost 3 plus. So this is salt ion, conjugate base of the acid, because it has lost its H plus. When an acid loses its H plus, it forms a conjugate base. So now we've got the phosphate ion. We're going to make salt from phosphate by combining it with metal ions, group 1 metal, group 2 metal, and group 3 metal. We start with sodium plus. This is the oxidation number of sodium. Because sodium is in group 1, sodium will lose 1 electron. Therefore, it becomes sodium plus. The phosphate has 3 minus. Sodium has 1 plus. The 3 goes to sodium subscript. You go Na3, and the 1 goes to phosphate subscript phosphate 1. That's sodium 3 phosphate or sodium phosphate. Phosphate 3 minus and calcium 2 plus. Calcium is in group 2. It will lose 2 electrons to become calcium 2 plus, and forming the compound 2 from calcium 2 plus, we go to the phosphate here in subscript, and the 3 from phosphate we go to the calcium subscript. So you get calcium 3, phosphate 2. For potassium in group 1 and phosphate is 3 minus. Potassium is +1 because it's in group 1. We will swap the value. So the 3 we go to the subscript of potassium and 1 we go to subscript of phosphate. You get potassium 3, phosphate 1. So we call this potassium phosphate. Now phosphate with aluminium 3 plus. Aluminium is in group 3, so it will lose 3 electrons. That's why it's 3 plus. They will exchange 3 for the subscript, but because they're the same value, we just write aluminium phosphate because the ratio is 1:1. So we write aluminium phosphate. To be a salt, you have to have the salt ion, which means it's coming from its acid. You have to have a conjugate base ion. That's a conjugate base ion, conjugate base ion, conjugate base ion. It is these conjugate base ions that make the salt. So you see they come from their acid. If they don't come from their acid, which means losing H pluses, they will not be a salt ion. Hence, they cannot be a salt. The condition for being a salt is to come from their acid, which means they have lost H plus and they are conjugate base. Aluminium oxide is not a salt. Sodium hydroxide, not a salt. Potassium oxide, not a salt. Potassium peroxide, not a salt. Sodium peroxide, not a salt. Calcium hydroxide, not a salt. Calcium oxide, not a salt, because the oxide, hydroxide, oxide, hydroxide have not come from their acids.